Is my screen visible?
Yes, ma'am.
Yeah, okay. So this was the IR sensor and relay integrated model. So for this, we will be designing a layout today. For that, first you need to save this and go to the design part and say convert to schematic to PCB. Again, you can select any one of the options, board options, circular, round, rectangular, and custom. So for today's class, today's PCB, I will be selecting this round rectangular and make sure that the starting points are at 0 and the unit is in millimeters. And then press on apply. Now the layout part will visible now. So this is your PCB board. Make sure that you are placing all the components outside the PCB before placing all the components. And after doing that, you need to just go to schematic and select the component. Uh, as I already told that the bigger components has to be placed first, or the one which is the main important component, that one has to be placed first. And after that, you can place other resistors and capacitors. It takes some time to move. Then press K to fit whole window into your desktop. Now go to your schematic. Before that, save your PCB layout. After saving, it will give you the name called PCB IR sensor, whatever you have given the name. Now, firstly, I will place all the components of the DC power supply. For that, you can select the DC power supply unit here and go to your layout part, and you need to drag that so that all the components present in your DC unit will be selected and rent. Now place the components according to the schematic. Firstly, we have a P1, then a DC jack. So according to that, I will place. This is my connector, 2-pin connector. And this is my DC jack where I will be giving my input. And after that, I have capacitor, then resistor and LED. You can rotate the resistor so that the connection will be like straight lines. Then go to the schematic and select this relay part and go to your PCB again. You can see that components that are present in that unit are selected. Again, you can drag them. Okay. Firstly, the main component will be my relay, that is 5-volt relay. So I will first place that one, and the surrounding components like connectors and this diode I will place. If you want, you can rotate this. This is the negative terminal of the diode. This is the positive terminal. And LED has to be connected to the resistor. My resistor is here. And we have one more resistor, that is R5. And we have an NPN transistor. NPN transistor is connected to diode again. And we have capacitor C2. You can see that this is also connected to C1. So my C1 is here. This is the ground terminal. And these grounds are shorted. Let me place it here itself. And make sure that this orientation of component is proper. The line which is the double line should be facing to the outer border line. Even though connections may get crossed, but make sure that the component is placed properly. After that, again go to the schematic and select the sensor part. The main component in this sensor part is this LM358 comparator. Again, you can drag them. This my Before converting this schematic into layout, you have to see whether all the components are having footprints or not. For that, you need to, you can see here at the right corner, you have a footprint option. And I have assigned all the footprints here. So you can directly go to the PCB. Firstly, I will place this LM358 IC, and to that IC, I have a potentiometer. This is my potentiometer. The potentiometer will also be having three pins. One is VDD, one is ground, and one is output. At the output side, you will get a variable resistance. And we have a diode, photodiode, and a IR LED. And we are left with the two resistors here, R2 and R3. This is my R2. So we can again rotate the R2. And I have R3 here. And we have three pin header, LED and resistor. Now you can change your border length and height. For that, go to Tools section. In that, you have an option called Set Border Outline. So if you can see that I need to reduce my width, so I will make it as 50 and height is correct. 50 is very less. Again, go to Set Border Line. I will make it as 65 and it will be round rectangular. So this is like proper PCB border. If you want, you can bring these components to the bottom side. Otherwise, if you want to increase the height, you can do that. Again, you need to go to the tool section and increase the height like 56. If you want to move this border, you need to select all the parts and press an arrow key in your keyboard. Now I need to place the holes. The holes are present in the PCB tools. You can select that and keep 4 holes at the 4 corners. Make sure that all the holes are at symmetry. And with the placement of components, so you can see that there are the sufficient distance between the components. If you want to drag the components, you can do that. If you want to place the component in vertical fashion, you can do that as well. Now we will start with routing part. So is this clear till now? Hello?
Yes, ma'am.
Okay. So again go to this wiring tool and select the bottom layer, which one is in blue color. Don't select this top layer. You need to route all the components at the bottom layer as much as possible and press a W key in your keyboard and drag the wire. To increase the width, again press tab. And as I already told you that the DC power supply unit has to be routed at the copper width of 1 mm. So select a 1 mm width and make proper connections. This has to be connected to the V-in pin. So you can see that the V-in is, you can short here. Try to avoid the straight lines like 90 degrees. Make 245-degree angles. So this is my sensor part. I will route it later. Firstly, I will complete all the DC power supply component routing. This is my ground pin. It has to be connected to the ground pin here. But I have middle tracks here. You can take some other tracks. If not, you can take a top layer and connect that. Let me see. Firstly, I will connect all the easy components. For this routing part, I will select the wire as 0.7. Minimum should be zero point 0.2. Don't go beyond that. Like if you do auto route, it will select all the default paths as a minimum one, but it is not preferable to do the auto rotating part. Do a manual routing here. So start with all the easy tracks and then you can do the other parts. You can take the parts from like inside the components. It is not an harm. You can do that. If you want to take a track between these pads, you can do that, but you need to reduce the width. I will do it as a 0.4. The whole path should be in 0.4. Now this pin has to be connected to the resistor. Can do this here. Okay, you can short here. Now again select the width as 0.7. This resistor has to be connected to this relay. We complete this part here. We can delete this wire. Firstly, I will connect them. And I can take a path here and I will short here. So here I have to be like it will not allow me to cross this line. So I will take a wire here and I will connect using a top layer copper layer. The red color indicates the top layer copper layer. So again I need to connect these lines, but in middle we have two bottom layer tracks, so it will not allow me to take the path in bottom layer. So I will take a top layer and I will do the connections here. I guess we have one more connection here. This ground has to be shorted here. So again, I can do it in the top layer. If you want to route all the connections in the bottom layer, you can do that. You need to search for the paths where you can do the direct bottom layer connections. So if it is not possible, you can make use of these jumpers and wires. This is the layout part. Save your layout and check whether all the components have the 3D model or not. So my three devices have no 3D model. D1 is my LED. This is my photodiode, I guess. If you are not sure, You have to go to the schematic again. See, this T1 is my photodiode and TX1 is my IR LED. Again, I will go to the layout part and select this D1. This is my D1. Again, go to the 3D model option and type a photodiode here. In the user contributed, check for the 3D model of the photodiode. This is not the photodiode. Photodiode exactly look like your LED. If you are if you don't know how the LED like photodiode looks, you can go to the Chrome and search for the photodiode. Okay. So this photodiode is it looks like your LED only. It can be a different type also. This is one different one and this is a different one. You can select any one of them. I will take this one only and I will do this Z as 5 mm or minus 5 mm so that my component is inserted into the footprint and go to the next part that is the relay. So search for relay. Again, if you don't know how the relay looks, you can go to Chrome and search for relay. So this is how the relay looks. It can be yellow, sorry, it can be blue, it can be in brownish color or black color. So the relay has to be of 5 pin. Type 5-volt relay. This is the one which is in blue color. You can select that. Change the orientation. My 3 pins are here and 2 pins are here. So I need to again rotate this. The orientation is not correct here. You can do this later. Search for IR sensor. Again, if you don't know how the IR sensor looks, you can search here. This is the full IR sensor module. You should not type that IR sensor. I need an IR LED there, which emits IR like infrared rays. This is the IR LED and this is my photodiode. This is my full IR sensor. So I will be searching an IR LED. It has no IR LED. Let me again go to schematic. You can see that this IR LED is also like looks exactly as a LED. You can give the 3D model of your LED to this IR LED. You can increase the height and width of this LED. Now we have left with this LM358. Again search for LM358. Press on auto. This is the LM358 IC. You need to change its orientation. So the round hole indicates the first pin. So this is my first pin here. You can see a circle here. This circle has to be sitting at the circle of my footprint. This is the circle. It indicates the first pin. And here also it indicates the first pin here. So I need to change its orientation so that they both coincide. Okay. Now it is sitting properly. You can see that the footprint hole is exactly at the same one where my IC also has its circle. So you can update after doing all the after assigning all the 3D models and update it and cancel the window. You can save the PCB and to view the 3D model, go to the 3D view. So this is the 3D view of your IR sensor and the relay module integration circuit. IR sensor, the relay is not updated yet. Let's see again. After assigning a 3D model, you need to update. Otherwise, it won't be get updated. This is my photodiode. And I have IR LED here. So IR LED will be in like white color, but in my 3D model, I don't have any white color, so I can select any blue, green, or red color. Update it. Again, my LED has not got updated. Now all the components have right marks. Again, save the PCB and go to the 3D model. So you can see that all the components have got updated. Here will be your relay output, and this is your IR sensor. One will be VDD, one will be ground, and one will be your output pin. Here you need to give a power supply. If you want to give the name to this circuit, you can do it using the text. Okay, is this clear?
Yes, ma'am.
Okay, so tomorrow will
Ma'am,
be
that
a
were read that were removed.
sorry,
The components that was showing red in cross sign
where
that were removed for 3D model.
if it is not having any 3D models, it will show a red cross mark there. Is that your question?
Yes, and when we check the 3D model of the whole circuit, then it will show the component or there it will be missed.
No. When you select a 3D model for one component, you need to update. If you do not update that and you go for the second component, it will not get updated. So I have done the same mistake now. So don't do that. You just if you have assigned any 3D model, just go for update and then select any other component.
Okay.
And in this, like in layout part, you need to check the 3D model, and in schematic part, you need to check the footprints. If you want to check the footprints, so the again step is go to the component, and at the right corner, you will be having a footprint option. Again, check if all the components have the right mark or not. If it has cross mark, you need to write the component or part name of that component and search for the footprint at the search option. And if you want to change the classes, it has four classes. If you have designed your own footprint, you will be getting it in workspace, and the EasyDA will provide like inbuilt 3D models like LCSC system and follow, and user contributed will be from the other users. If you are getting proper 3D models from the system and LCSC, you can select that. If not, you can go for the user contributed. Okay.
Ma'am, how to know which exactly 3D model I need from the many numbers?
You need to like the component will have having many specifications. Like in this case, I have selected a 5-volt relay. It can be a 12-volt relay also, but according to your specification, you need to select that. If you want a 5-volt relay, you have to search for 5-volt relay. If you want a 12-volt relay, you need to go for 12-volt relay. Just write all the specification of your
Many
component.
components show for 5-volt relay.
The one with a proper pins and one with a proper 3D diagram, we can select that. Thank you.